It's good. I look forward to that.
Well, it's not that hard. Like you have just to.
No, it's just a lot of code changes, but it's not technically that difficult.
Yeah, because all the ephemerate again. I've been using the Astro time there. Yeah, it makes a lot of things easier. A lot of them. Like Julian dates and Julian dates in different decades and stuff.
Well, we already use it for tie time in JSOC and various other things because it was the only sensible solution. And it's all of coordinates already uses it underneath. And anyway, you're here this week, David, so you can do this bit. Go forth and
Which bit?
The student bit.
Oh, okay. Well, we have today only Tessa, which is the first time I am.
She was here last week.
No, the first time for me that she is. And Alex, who wants to make a demo. Alex, do you want to go first? Or
if I could have 5 odd minutes just to make sure everything's...
Sure, okay, so Tessa, would you like to give us an update of what you've been doing over the last week?
Sure. Okay, good morning. Well, I implemented some plots, or I implemented some parts of the code that have allowed me to create plots that I put on my blog in the past week. But in the past few days, I've been refactoring a bit with my mentor's suggestions, such as I pulled out the file or the function that reads the .genx instrument files outside of the response function that I'm making, or the module that I'm making. And so that will be a separate script. And I'm just making sure the gain part of my wavelength response is correct this morning. And other than that, I plan to move on to the emissivity part, which is going to be the SunPy, starting to dive into that. We kind of discussed that last week a little bit. But yeah, for the most part, so far, I've just been refactoring this week. I haven't changed too much or moved forward as far as that is concerned. Let's see. I think that's about it.
Cool, thank you. I put the link of your blog on the chat for
Great.
the people who want to see the plots, because they are nice, at least for me, that I did it.
Yeah, thanks.
Yeah, any comment from anyone? I'm gonna say. So you haven't started to play with SunPy yet?
No, I've
Okay.
looked into it as far as line lists are concerned. Will was saying we're going to have to probably not only implement it, but change it a little bit to fit our needs. So that I have not gotten into quite yet.
Yeah, I'm just wondering how will be, because maybe you will be the first one using SunPy from GitHub, and maybe like even to contribute back to them. I don't know, because SunPy has been just created by one person.
Right. That was the discussion last week.
Okay, so
yeah.
Looking forward to that.
Cool.
I just imagine like SunPy using units and stuff. It will be a lot nicer.
Well, that's actually something I've been testing out this week too. I was using a data frame, or I had been using a data frame that I pulled the information for this function into. But I'm looking into SunPy table to use instead. I'm not as familiar with loading it and getting it at one index or one element in there, but they house units, so it may be a better structure. Kind of testing that at the current time.
I haven't played much with that, so I cannot really I don't really know. But so you say to take one element from the table.
Yeah, SunPy tables loads in very easily by columns, it looks like, and I'm trying to save like the data type information and the unit information in there. So I'm still kind of learning how to access the different elements in it.
Can you just index it?
Yes.
Okay. I don't know. I Stuart was me who was teaching that in Sheffield, right? Yeah, I think so.
The SunPy table stuff.
Yeah. Okay. So yeah. So I supposed to know, but I haven't used it since then, so I don't remember. But yeah. Well, cool. Thanks. Alex,
Yeah, sure.
ready?
Well, I hope so.
Are you going to screencast or?
Yes. So
Cool.
just give me a second.
Sure.
Move out of window. Boo, 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 boo. The screen. Oh, darn it. I need to add an extension. Oh no, that seems to have done fine. No questions. So screen 2, share. Right. So can people see my screen?
Yes.
Right. Okay. Well, let's first of all restart the kernel so you don't have all of my previous rubbish. So for those who need reminding, obviously this is the time series class, which is meant to be replacing the light curve. So it's kind of more generic, more powerful. It's worth me saying at the offset, there are some features of light curve. So for instance, downloading data that is not part of the time series. Obviously, that would be part of Unidown. So it is worth saying that has been cut out at the moment, which is why I have an example gallery which is online on my my fork or branch? I can't remember the terminology, but within that it does actually include a reference to light curve just to download some sample data. So please ignore that fact. That will obviously be fine once Unidown is up. Anyway, but essentially, if I start running through some of the functionality that's currently available, and the big thing is I sort of want, at this point, people to start playing around with it, breaking it, getting into the debate on how we get it running. So the primary thing is that there's a subclass for every source. We have the same kind of structure as with map. So we have a time series factory, which will take a series of different inputs. And essentially, it should be reasonably versatile. But if I go for the very basic, which is if I give it some of the sample data for the Eve, then of course I've got now an Eve time series. We can peek at the moment. This is just stealing the code directly. So you can peek as normal. In fact, I should do type. And then no, that was not. And so obviously you got the normal plots that you would have had with light curve. That's all just refactored codes. It's not. I haven't done anything with that specifically. Obviously you can. I could show you all of the individuals, but it does seem a little bit pointless. I know that later on I'm going to be using the goes data, so I'll throw that in and we'll show you that in a minute. You can actually, again, I'm using the light curve to download the files here, but they're already downloaded on my system. So you can actually, like with the like with the map object, you can load multiples all in at once. And in this case, return a list if that's what if you've not specified anything special. So of course that's just a list of light curves, each of which can be accessed. And again, a figure comes over into the other screen. But, so there is your figure. But you can also, you can do it obviously with more files if you want. You can also concatenate. Now, I'll show you the concatenation function in a second. But essentially this at the moment has just returned a single time series, which obviously you can't see the old one so easily, but essentially that is actually concatenated 2 days worth of data, and so that's a function which was completely missing within the original archive.
Alex, is time aware of the concatenation, or is it a concatenating? So if you put two files with the same time, it just
Right. So well, it's not the files which are time aware. So obviously
no, the data. I mean, if
yeah,
the
that's
data,
it.
so
Yeah.
it will plot if it's the same.
If
If
they
it's
have exactly the same timestamp,
and it's the
then
same type of
and the same column header data, then it will when you're concatenating, there's normally an original and something you're concatenating with it, and at the moment it would default to using the original. Obviously, there are potentially times when that might happen, but generally that shouldn't be a major issue in the sense that it's unusual you'll have two files with the same timestamp for the same type of data and yet two different values. But that is so the concatenate function, which is independent. Obviously, this just calls the concatenate function because it's set to concatenate true. The concatenate function itself is a little bit of a dark horse. So am I being? Yeah, you can concatenate manually. It's a bit of a dark horse. So there's two major issues, which is one, what to do in those particular kind of fancy cases, and two, what to do with the metadata in every single case. And those are things which are going to need a little bit of debate and potentially a more advanced way of coding. I mean, if I look at, I might as well show you, seeing as we've already sort of mentioned that, the meta in here at the moment, I'll give you a bit more of a space of view. So for only concatenating two time series, it's reasonably easy. You've got the first metadata and the second metadata all stacked within your metadata, but because it's an iterative process at the moment, you only concatenate one at a time. So if you're doing a concatenation of 3, it will do the equivalent to two concatenation commands. So if I show you what happens when that is done, and then I bring up the meta on that, you'll see what is currently a bit of a problem. So now what we've got is we've got the two nested meta from the first concatenation, all nested in the second concatenation as the first position. And then obviously there's the second one is nested there. So you can imagine this is going to get unwieldy if you're concatenating 4 or 5 different times. But that is something that we definitely need to consider. Danny, Stuart, and I have been discussing it, but the problem is we haven't found sort of a single good solution. And slowly but surely, our solutions are getting more and more complicated. And so that might require a bit more talking about actual usage case before we can put a decent. But the main functionality is that you can concatenate. You can actually concatenate. I don't demonstrate it at the moment because it's a little bit less reliable. You can concatenate not only the same data source, but you can concatenate different data sources. It's worth me mentioning that when you're calling, so this is obviously calling the time series factory. When you're calling the time series factory at the moment, it can only work if you explicitly state the type of time series it is. So it doesn't implicitly check. We will be doing that, but obviously that potentially won't work for everything because not every file type is coherently obvious what data source it is. And then equally, there's we've kind of assumed that you will only ever use one data source when instantiating the factory. So it's kind of a limitation, but it's just because otherwise it would be so complicated, because unlike map, where pretty much everything's in FITS files and you know what source of data you have, with this you don't. You have to explicitly state it potentially.
one thing, so for plotting,
Yep.
it doesn't. So you can plot together two different light curves, time series instances, right?
Yes.
So it doesn't really matter. So if I want to plot two instruments, I can just as a map, I can do a map and then do a composite map, which would be like, for example, with two different sources. I could do the same with light curves, if I'm understanding it right.
Right.
So they don't need to be in the same object. They can be, or I'm wrong.
The composite map, that's one thing. I don't have a clue what the composite map actually does. I've never used it.
Well, just thinking as two different, if I just have two different instruments and you get there two different time series objects.
Yep.
One for ghost and one for Eve. You could, if they're in the same, well, if they're whatever, you can plot them together.
Okay. Well, you could potentially do that if you were to create a manual plot. But at the moment, as far as I'm aware, the only way to plot them together currently would be to bring them into the same time series. But I am aware that that's potentially something we want, something like a composite time series. At the moment, we don't have that. That is not part of the spec per se.
Yeah, sure. Okay. So right now the plot is only what is in the same time series. Okay, good.
Precisely. Yeah. But do remember though, and this is where at the moment you can actually create a manual time series based on just placing in your data. I'm trying to think where I actually put the methodology to do it. But you can obviously, if you wanted to create a more advanced plot, and this is one thing where concatenation will work in a lot of ways, but at some point, if you're concatenating a lot of different data, it's actually kind of more useful, I think, to start thinking, okay, well, why don't I create a new generic time series rather than trying to use one of the source. It's concatenating goes data to Eve data may cause more problems than just getting up and saying, okay, well, I can get the goes data, I can get the Eve data, obviously using a time series. I can then extract the data as pandas, combine those, and then create an entirely new time series, which is my own time series for whatever I'm analyzing. So, but that's obviously a question of use case. So within the object itself, you've got access to all of the primary things. So the data, which at the moment it's using Panda data frames. Oops, I haven't actually loaded Lyra in. So obviously the debate about whether to use anything AstroPy, unfortunately at the moment there is no suitable data structure. So Panda data frames is what we got. You've obviously also got the metadata, which again can get confusing if you start concatenating, but for a simple perspective, the metadata is just as normal. We also have a units detail. Now this is a dictionary, and this is basically the way that we currently bolt on unit support to the time series. So I'll explain that a bit more in detail later, but essentially all it does is it matches the column headers to an AstroPy unit type. And obviously you could change it just by, it's a dictionary at the end of the day. Again, we have access to the more specific details, but most of these haven't been populated. This is actually a part where it's actually a part where we start to need deciding use case and what of these particular values might be useful. So I've essentially stolen them mostly from the map class, and we want to decide whether we want to keep them, get rid of them. So that's all a part of the debate and the ongoing debate. Obviously, it's worth saying that with the plots, you can plot them with subplots as well. So it's essentially exactly the same plotting mechanism. It's taking a second to render. Exactly the same plotting mechanism as you got with the old light curve. So again, I've just ported that code over. So you can also extract individual columns if you want. And then obviously from that, again, I can just look at the data. So that's just extracted the one column of data that I want. Again, that could be useful when you're concatenating to get rid of the columns you don't want and only include the columns you do want. That's actually incorrect now.
So concatenating adds more columns or add data under the columns?
If the columns have the same name, then it will add more rows.
Yeah.
If on the other hand the columns have different names, then it will obviously add new columns.
Cool.
So,
Thanks.
and equally, it will concatenate the units dictionaries as well. So essentially, it should remain a functional time series with a concatenation. But again, the metadata is the real kind of pain in the arse when it comes to concatenation.
Yeah, well, also two maps.
Yes, yeah, that's it. So, okay, so truncation is one of the big features, again, missing from the light curve series. So here we have three different methods of truncation. You've got truncation via simply using the indexes. So in this case, it's very similar to slicing, except that it's not slicing. In fact, I think this is just, it's doing alternate. So it's going to be looking like the same original data. But we can also use a SunPy time range. So you could just throw a time range in. Or equally, I think generally more usefully on a day-to-day basis, you could truncate using text string, using strings for a date time. So, and that uses the SunPy parser now to pass that. And essentially all it's doing is it's turning those into a into a time range, a SunPy time range, and then obviously it'll it will enable you to truncate it. So essentially, you could concatenate to make a larger data set. You could truncate to make a smaller data set. And so, for example, on the goes data, if I show you the original goes data, actually, it will be a good comparison. And then I show you the truncated goes data. Why that's raise error depreciation warning. Is that okay? I don't know. Oh, there we are. What's going on here? Let's admit, whenever I'm plotting, I do have these weird problems. Like it's trying to do something in the background, but it's not telling me, and it's got the plot, so I don't quite know why. Well, if I do that. So, right. So say we have the original time goes data there, and say we wanted to zoom into a particularly active time, then obviously we just truncate it to the time that we care about. So in this case, we truncate it to that region there, and you can see it's nice, more legible in the diagrams. But other than that, they're both exactly the same. They're both of the same type. They're both goes time series, which means that the plotting all looks reasonably similar. So yeah, that's obviously a reasonably useful function. One of the good things is we have the ability to downsample or to resample full stop. Essentially, it just resamples the data using the internal pandas data frame and whatever pandas functions you use. So for example, this is exactly the same data. I've downsampled it quite massively, so now it's much smoother.
Before you go in that way, like in the truncate, the first example you show is just every 2 elements you're taking every other entry, right? Can you do the same with the times? So can I put just the time range and say every 10 minutes?
You can, right? So that would be in resampling. So that's what this is doing. So when you downsample, in this case, it's saying every 10 minutes, and then it's saying take the mean of those 10 minutes. And you can use mean, sum, or standard deviation. I don't know whether there are other methods. That's annoying. I didn't notice the pandas where it actually lists out what the overall methods are. But yes, so when you're resampling, in this case, when you're downsampling, obviously yes, you can take every whatever time.
Thank you.
So and then equally, obviously, you've got the exact opposite, which is you can upsample. And so in this case, it's taking that same downsampled, which is every 10 minutes, and it's upsampling it to every 1 minute. I don't know why they have T for minute. That's just a notation that pandas use, but I've tried to obviously maintain that notation.
Is it time step?
No, so T explicitly means minutes, and then H means hours.
That should potentially be AstroPy time instead. Not AstroPy time, AstroPy units even.
Oh, please don't. That's considering I don't even have a comprehensive list on what these things mean in pandas. I know T, I know H, I know M for minutes, but I can't. There's no.
Well, that's all you need, right? Because you could just, if you get a unit in, it doesn't matter whether you go down to seconds or whatever, right?
I didn't say I had seconds yet.
No, but I mean, like, you could go down to minutes, assuming it takes decimal minutes, right? Yeah. It doesn't matter. You can just transform to 1 unit and pass it to pandas.
We could have a play and try to figure out that.
From a SunPy API perspective, it would be more consistent if it.
No, I agree. Unit. And it's reasonably easy. In this case, it's using a string, so it's reasonably easy. You could check if it's a string, just use it as is, and if not, if it's a quantity, then obviously convert to said string.
That's the functions that you have there, the mean, the sum, and the standard deviation. Those are the standard ones by pandas. Do you know if you can add other functions?
You can pass in an arbitrary function in this way of calling resample. I'm not sure that they have a newer way of calling resample that may not be as receptive to user-defined function.
Well, yeah, so the current, so yes, our resample is just mapping onto their new form of resample. So essentially, yes, what this is really doing, to the pandas data frame is it's saying dot resample, then it's and then it's dot mean, I think, something like that. So that's how the data frame uses it, and that's how the it's actually sent to the pandas, even though we've written it with a notation like this. This is actually their old style of notation. I don't know why they changed to that style. I think it might be specifically so that it is easier for people to add their own functions, because essentially, like this, you're locked into whatever they've restricted as options.
No, in the old style, I believe you can just pass in a function there as that second argument, and I believe it works. So I actually don't know with their new style how you're supposed to pass in an arbitrary function.
That's a worthwhile thing for me to throw up on my list of things to research.
Yeah, I believe you can just throw like np.max or something like that, or other fancier things in their old style. I don't get their new style.
Okay, well, I'll have a look into that. It's a worthwhile thing for me to check out. But yes, at the moment I don't actually know. Beyond using the standard ones, I don't actually know. But it's definitely a worthwhile thing to see whether we can implement, because it'd be useful. I assume it shouldn't be that hard. There's got to be some way. I mean, it'd be stupid for them not to have given some kind of functionality for it. But yeah, so obviously there's downsampling is simply using the resample, but with obviously larger time ranges than you originally start with. Obviously upsampling, you again use a shorter time range, and it will interpolate. So in this case, I don't know why it does this. It seems to pad it out, but not fully. But that's just what you get from an upsampling process. So we turned it from a smooth, low resolution curve to a slightly more jagged, higher resolution curve. Again, that's just using the pandas function. So I can't take any credit for any complex coding. I'm just throwing the stuff over. We thought it would be worthwhile to be able to convert from a time series into various different data forms. So, for instance, to have you can obviously get the data frame back. Now, if you do .data, at the moment, it does obviously return that original data frame. But it's kind of important, in our opinion, and for the general projects, that we're trying to be agnostic to what our internal storage is. So essentially, I don't really generally think people should be using the pandas data frame itself when they can avoid it, because it makes more sense for them to use our functions. Then if in the future we find that there's if for instance SunPy creates a time series style storage mechanism, then or a suitable table which has time series support, then we can port over to the new data storage without users having their code suddenly becoming redundant. So we've also got the ability to output to an SunPy table. And one of the sort of useful things, I think, is that we actually have units porting over. So in this case, it's counts. Admittedly, one of the things is I believe I've got the units correct. So the units are currently hard-coded within the instrument classes themselves. I believe I've got them correct, but anybody who actually uses the data on an individual instrument would probably have a much greater understanding as to, because I've only tried to read the documentation and they haven't always made them totally clear to me. But yes, so that supports units, which I thought was quite important. And equally, obviously, you can easily output to an array. So if all you want is the actual number data. As I've said, you can create a time series from scratch. And so if generally, obviously you can from a pandas. Admittedly, for some reason, from pandas hasn't worked. From a data frame doesn't work right now. It was working yesterday, so I've got to see what the issue is. But you can create it from an array. So in theory, .data. So that's just created it from an array, and it should be able to peek. Obviously, it won't be anything impressive, but that is the array that I gave it of 2 columns. Likewise, you could create it from a table, SunPy table. And so once again, we can do with one less e. And so again, a very basic example, but just to give you the idea that you can actually use AstroPy tables. You can also explicitly, if you obviously know what units you're going to be using. So it would default, if you don't give it any units, it would default to unitless or dimensionless units for all of the data. Whereas if you give it units, it's smart enough to understand that actually there are units there. So again, if I do .p. So again, exactly the same has been created, but more importantly, I can also get the units. It will, in this case, it's dimensionless units because, no, wait a minute, that's interesting. From table. Huh, okay. Well, that's not working right now. It was working the other day. So, oh well, live code, what can you do? But yeah, so the whole point is it's meant to have brought in the units that I've thrown it. So I've given it just an ordered dictionary for the units, and it's meant to be able to port those across. So, right, okay. You can obviously change the units by changing the value within the dictionary itself. That's reasonably self-explanatory. All it is a dictionary. One of the important things, which is going to be harder to demonstrate, oh no, because I'm demonstrating from an Eve. So there's, right, let me see, you can overwrite a column. Okay, you can overwrite a column. I haven't demonstrated how you get the quantities out, which is interesting. I should have done. So let me get time series. It's got Eve dot quantity, and then let's just grab some column from Eve. If I can remember a column from Eve. Oh, no, so that's it. So you can extract a quantity reasonably easily. It would just, at the moment, you can only extract the column quantity. So in this case, it's a normal quantity. Obviously, you could just extract the column if you want. You don't need to extract the quantity. But clearly, that's going to be less insightful for our work. So, sorry. So that would just return the, oh, in fact, this returns the pandas, so a time frame. But potentially I want to make it so that you can return without quantity and just to return the array, but primarily we can return the quantity itself using that quantity function. I've got to admit, I've been trying to put it so that you can update an entire row, including using quantities for values within the row, but at the moment that's not really working out too well. It's something I need to talk to Danny and Stuart about, but it becomes very unreliable because obviously each column will have its own, potentially its own units, and then you've got to convert. So it means you've got to throw in a list of quantities and you've got to convert each of those, and then also there isn't a very easy way to access an individual row. I've found, or I don't seem to be able to find a way to access an individual row easily within pandas because their indexes aren't always using the same forms. Obviously it's fine if they're date time, you can access it, but I'm currently struggling to find a coherent way to access them. But yes, the idea is that you can also potentially modify the values within a okay, that's odd. U equals u dot quantity. Oh, q to value. Yeah, I need to. I've changed it now to, right, there we are. So if you're using a quantity, that is a quantity value, which I've collected from the row. I can then modify that quantity value. And so now it's going to be different numbers, nothing special. So, and then finally, I can obviously throw that back into the original table. I've got this overwrite equals true. It defaults to true, but it's worth making sure I highlight that. And essentially then we've just updated the values within that time series object. So data, obviously I don't expect you to necessarily remember what the original values were, but we have updated, if I can figure out which column did we use. We use cmlat. So that column has been updated, and I say you can. It would be easier for me to show you if I had a bigger screen resolution on here at the moment, but I don't. And exactly the same can be done. You can throw in just an AstroPy NumPy array. So yeah, you can put in quantities, you can put in arrays, and it will figure the rest out. The update row stuff at the moment, as I say, that's causing trouble. But essentially, that's where we're up to. The main reason I wanted to demonstrate it was to give you guys an idea of the sort of functionality that's already in there. Again, give people the opportunity to start playing around with it. This is all within my branch, and then the time series branch. And hopefully then we could start discussing some of the more fine detail, like especially that meta concatenation. So yeah, are there any questions?
Cool, thanks. For the, maybe you should make a pull request with that branch as Tessa is doing.
Cool.
And that you are going to be updating so we can see there where it is. And the other thing I was going to ask, in the when you are the operations on the time series, like the pandas, right?
Yeah.
Do the units get updated depending on the operation you do?
So
for example, when you have a flux which is per second and you do a sum, how do the units change?
Right. So at the moment, nothing. The units don't
when
change,
the unit
for
is
example.
time dependent and you have you do operations on time, the units have to change, right? Or maybe I'm confused now. But
if you're so it depends on what you're doing, and that's where the problem will become. It depends on what operation. If you're summing it, then the units should stay the same. But obviously, if you're
no, if it's per second, and you add a minute, and you have a data per minute, then the units will be per minute.
Well, no, because the unit is still per second. Because you've added them together, then so you'll have 60 times as much. So say you added 60 1-second increments together, you'll have 60 times a bigger number.
But you have a value which is 60 points into one. That cannot be per second. That's how to be per minute.
I'm getting. I'm trying to think here.
If I have a bucket of water every second,
yeah,
and then I join them into 1 minute, I will have 60 buckets of water. So that will be 60 buckets per minute, not per second.
But you're saying no, because you're. Oh, right. So yes, yeah, okay. I see what you mean there. But I guess it depends on whether the problem is whether you're using count or flux or, and that's where.
That's what I say. So how the? I mean, I think that they will.
At the moment, it doesn't manage that at all, and so I think that's
And that should be something like the function that the person will introduce. It should have also a function for the units or something. I don't know. I don't have a clue how to do it. It just come to my mind.
Yeah, no.
That's something that people could be, believing blindly on the units and then get something like that, which could be wrong.
Yeah. I'll just write that down as a note. But yes, I mean that's going to be a very difficult sort of nitty-gritty detail when it comes to use. Because yes, as soon as you start resampling or anything, then you're going to have issues with units. You obviously what you're doing with the data, and that's where I don't know if there's an overall structure you could say, well, in every case when you're doing this, you can do it that way.
Yeah, but I think this would be something that we should warn the people, because if they get a number and a unit, they may believe it that is done under the hook and be wrong. I don't say that it's wrong. I'm not sure, but yeah, something that we should warn somewhere. I don't know.
Yep. Talk that over with Danny and Stuart, see what we can think about.
Cool. We don't have more students. Any more questions to Alex?
Yeah, I have a question. Doesn't the header become time dependent then when you concatenate?
When you say the header, the meta.
The meta. Sorry, yeah.
Well, that's where it doesn't. It depends on what you're concatenating. If you're concatenating the same data so say the classic example I'm giving here is if I'm concatenating goes data. Okay, so over here, sorry, my screen isn't shared. I shall share it again. If you're concatenating goes data, like I do on this line here, then no, oh, sorry, then yes, it is time dependent. But you've got to remember, if you're concatenating any other type of data with goes, for example, so say you want to concatenate Eve with goes for whatever reason, then of course they might still be covering the same time range. They might obviously have different different cadence, but they'll still be covering the same time range. And this is why it gets complicated, because there are two different kind of use cases for concatenation: either homogeneous data or inhomogeneous data. Obviously, homogeneous data is reasonably easy, because yes, you then get up and say, well, okay, I can keep all all of the metadata, but give it just time dependence. But unfortunately, if you're then doing inhomogeneous, it gets very confusing. And so yes, I'm not sure what the solution for that will be.
And what's the use case for inhomogeneous data?
Generally, if you wanted to compare results from multiple instruments, I mean, again, I can't say for sure, in the sense that I have never used a light curve or time series in this case for actual science. But it seems reasonably normal to me that there are going to be times when you would want to have more data from multiple sources together.
I'm not sure they should be concatenated into one. Like if I have I don't know, pandas per fortnight and electrons per gallon, then those, I can't put those two together. They have no meaning.
Well, but what if you have the X-ray results from one satellite and the X-ray results from another satellite? And then you want to compare, you will then be able to say, well, actually, this peak and that peak are roughly at the same time. Therefore, we assume it's spread over a wider area.
Then you will need to have a plot where the two axes are independent. Like for example, the left axis is from the one plot and the right axis is from the other plot. If there are different units and you're just comparing time.
But what if they're the same units? I mean, most use flux.
Well, no, if they are not in the same units,
But there are quite a lot of times when it will be the same units, and the only difference potentially will be the temporal cadence, the actual cadence of the data. But it still seems reasonable that you could plot them on the same graph at the same time without too much of an issue.
Yeah, you can, but they don't need to be inside the same object.
And if that's what we want to do, I don't mind. I just sort of, to me, it seems like a reasonably logical usage case. I can imagine people wanting to have the data from multiple things in the same object.
That's why I was asking before whether you could plot different objects together, because you may have a X-ray light curve and a particles event, and you may want to plot them together. But they are different. They have different units and they have different time cadence, and there are different instruments as well. So,
well, I'm plotting different units actually is again another thing that I haven't actually thought about until right this second. And yes, that's going to be an interesting, because obviously yes, you can't plot, for instance, the flux on the same axes as the particle count.
But that's a plot. There are other you're only considering plotting here. What is the use case for having a single object? What transformations can I make on a single object that has inhomogeneous data on it that would be useful other than plotting?
Well, to be fair, when I say inhomogeneous, I mean inhomogeneous in source. Eve, for example, has inhomogeneous data from itself. So, I mean, as an example, I can't say off the top of my head, but so we've got quite a lot of different values with Eve. We've got a number which are fluxes related to things, but we've got also things which are counts, particle counts, I believe. So
that's fine, because the metadata describes the state of the instrument, right? The instrument can take multiple, can measure different things. That's fine. Like when you're having data from different instruments, then I don't see the use case for putting those together. I can't imagine a manipulation that in one object that would be useful.
I think not necessarily a manipulation, but for example, if you wanted to output the data to a table, then it's convenient to have them all in one object, and then they're all in one object to output as a table without having to faff around. Obviously, you could get up and say, well, I could create the table from the two separate sources manually, but it then adds another layer of complexity to the overall operation.
I'm still not complete. I need to think about it a bit more, but I'm still a little bit. I don't know. I'm not convinced that having multiple instruments in the same time series is something that we necessarily want to be encouraging. I know it's something that pandas can handle quite well. I just don't know whether there's enough of a use case for us to handle it in the time series.
I mean,
but
I would say things that might be relevant include not necessarily having multiple instruments in the same time series, but other information about instrument states in the time series. This might be a natural way to store that. Whether it comes to, for example, in a RESI time series, what the attenuator or decimation state was. Those are more technical-based examples, but I could certainly imagine situations where we have other time-related information that's not just raw measurement that we want, and we want to keep coupled in the same object.
Well, that's just extra columns, right? I know technically so is extra information, it's extra instrumentation, but that comes with a lot more baggage than just on this time step we recorded this piece of data, and there were these properties. It's just
well,
extra
you could imagine that
columns.
other properties might be reported and transported under a different scheme. So it may not necessarily be like easily like partitioned to exactly the same sample across the board or something like that. The lack of, I guess, flexibility is a good thing because we can't imagine exactly what this will need to hold, right?
I'm not saying concatenating our objects together if they're different units, different instruments, basically. I don't know. I need to think about it a little more, I think.
Yeah, I think the problem is there's potentially options for using it, but I do agree that as a general rule, I can imagine that not having it wouldn't be the end of the world. It wouldn't make the time series much less functional. And so maybe it is worth cutting it out for now just to make it simpler and more easy to manage. But I say I don't mind. That's sort of one of the reasons for bringing it up, that it is a big question mark, and it will require a little bit of thought on how we implement. Oh, Jack comes back and Albert disappears.
Cool. I mean, yeah, I just think about it a little more anyway. Has anyone got anything else they want to talk about?
I've marked for review all the Unidown branch pull requests for review, so please do review them. Everything that is in review.
Okay, I'll take a look at that.
Okay.
How was that? Yeah.
What?
How has that project been going?
Oh, well, we have a lot of clients now. I just need someone to experts in different places to see whether it's good for them as it is. We have to look into Unidown, how to make it in a sane way. There is some places where there's a bit of repetition of code. I'm saying like we need to discuss in more detail. But we can wait. That's is in the call.
Cool. I will take a look at them. I don't have anything else. I don't think we need to talk about unless anybody else does.
Nope. Thanks.
Nope.
Cool. Thanks, everyone. Thanks, Alex.
Nice, cool.
Thank you, Alex.
Nice
Yeah.
talking to you guys.
Thank you.
Sorry if I bored you.
Bye, everyone.
Bye, everyone.
Bye.
Bye.